All right, so the first step what we're going to do is I'm taking my soil sample, which is really a fine aggregate sample, but again, for what we're doing, they're all going to be close enough. I'm going to get to SSD, so I'm just going to start adding water. I'm going to mix it. This is called a pouring cloth. You don't need to really include any of this in your procedure just yet. I just want to show you this will be in a later lab though. So all I'm going to do is I'm going to get this mixed up really well, and I'm basically going to add water until I can just about make a hand cast, but it falls apart immediately. So let's add a little bit more, give one more mix, and then what I'm going to do is I'm going to fold it up. I'm going to let it sit for about 20 minutes. That's close. I'm going to let it sit for about 20 minutes just to make sure all the moisture is kind of evenly distributed. Let it soak in evenly for a little while, and then I will continue. So that's about right. Maybe a little on the high side. That's about right. So this is about what it looks like at SSD. So all I'm going to do is I'm going to fold it up, and I'm going to come back in a little while. Good. So we've let this sit for at least the last 20 minutes. Try not to make too much of a mess in the lab. And that's about SSD. I can make a hand cast and it basically immediately falls apart. So that's close enough to SSD. So what I'm going to do is make two samples. So right over here. I'll pause it. Alright, so what I'm going to do is I'm going to make up two samples. First one will give you for moisture content, so I'm going to take my pan, set it right here. I actually have a pan that's not meant for this. Tear that out, that pan on there. So that pan, my tare weight, 311.8. I'm going to take a little sample. This is not proper sampling or splitting method, but it is how we're going to do this right now. Okay, so that's going to be my moisture content. So up here it's going to be 426.7. That's this guy. And I think we're only going to do this once because I don't want to worry about doing it twice. Okay, so for lab procedure process 2, we're not going to do that. We're just going to do it once because why not? This is my GSP moisture, and what I'm going to do with it is I'm going to dry it. Procedure may or may not say it has to be oven dried. If it's a cohesive soil and we want to keep using it, it absolutely has to be oven dried. The reality of the situation is sometimes you need to get it dried a little bit quicker. If I need results the same day, if I'm in a product for you guys, we've got to be Proctor, you guys need your results now. This is a lot faster of a method. So all you do to get this moisture content is it's going to be on here. We are supposed to consistently stir it. So I'll come back with these stirs here and there, and we will cook out all that moisture. Now I'll come back over here, get our second set ready. Quicker than not. Get this cleaned up real quick. I'm going to tear that guy out. So now what I'm getting is the mass of the soil. I'm actually going to put it in there. Again, this is not proper splitting methods, but this is not a official soils report either. So okay, so I think it's actually 1,000 grams. I don't remember exactly how much it says in the lab manual. I think for fine aggregates, it's 1,000 grams of material. For soils, it is 500 grams. We're going to split that damn near down the middle at 687.8. So that's going to be our wet soil at SSD. That is looks like 88.0. 88.0. So now what we're going to do is, once we get the moisture content out of this, out of that sample that we're burning, you will be able to get the mass of the dry soil. Okay, this moisture content and this moisture content are exactly the same. Okay, you want to pause that? Next step is I need the mass of this guy all the way up to 1,000 milliliters. Roll out. That gets me a consistent temperature. Fill this all the way up. Okay, and then when we're at the scale, I will add the rest. There it is. So, drawing the excess water off of this flask. What I'm going to do is I'm going to weigh it after I get this to exactly 1,000 milliliters. A little shy. It's close. Okay, so it's exactly 1,000. And that's going to go right here. So that's the flask and the water. So that is 1260.9. Pause. Okay, so before I dump all that water out, I want to get a temperature. I'll let that sit there for just a moment. And it looks like we're at 24 degrees Celsius. So that's going to go right here. And we're just going to let that sit. Pause it. What I'm going to do is I'm going to dump some of this water out. And this is an arbitrary amount. I just want to get enough of it out. And at this next step, I don't mess up my equipment. Just a little more. So, I dump some water out. I do not care how much. I just need to make sure it's down to about this point. I'm going to take my soil sample with that known volume after you calculate that guy. I'm going to add this to my flask and take it all and get in there. I got all my sample in there. I'm just going to make sure all the soil is off of the walls. And I really hope I didn't fill that up too much. I might have, but I guess we'll find out, won't we? So, use pumps. So hopefully I got enough water out of this guy. And so what I'm going to do according to the procedure is I'm going to de-air this. I'm going to de-air this flask, excuse me, I don't know why I showed up that. So basically we know that the known volume of this thing was only water was. We added soil. The soil has voids in it, right? Really small voids. When I was dumping it in there, they might have entrapped air. So this is where the ASTMs, and this is where it's going to differ between fine aggregate and coarse aggregate and soils and all that. This is going to differ, right? So for soils, the way that I'm going to run this is I'm going to put this vacuum hose in there, and we're going to vacuum out all of the air in this. It's going to sit there for 20 minutes, and you'll see the bubbles coming up once I turn this on. As that comes up, slowly but surely. As that pressure is building. let this sit here for 20 minutes, and we will come back after that. Pause it. So we had a technical difficulty and accidentally were taking pictures instead of taking a video, which is all right.
Sorry.
But basically all I did is I recognized that it was 20 minutes, which is the amount of time it was supposed to take. There were no more bubbles coming up out of it as the vacuum continued, so I shut off the vacuum, took it all apart, and I was starting to reintroduce water. So this water is the same temperature as the stuff I originally used, so I don't need to remeasure it. And I am going to carefully reintroduce water up to the same exact volume. Should be careful not to overdo it. Should be right there. So that's right back to the meniscus. So now I have the exact same volume as I did the first time when it was just water, except now it's water and soil. So I'm going to go ahead and take the mass of this one all over again and see where we're at. So pause. So now they have the same overall volume. My new weight of mass of water and soil, it's also flask, goes 1678.9. So the last component of this that we're going to need is our moisture content. This was dry, so I went ahead and turned it off. I'm going to move this over to the cooling rack, because it turns out things at different temperatures have different weights. I want it to be consistent. Put it over here, fan on. I'm going to let that cool, and once that's back at room temperature, I'm going to weigh it one more time. That weight is going to go right here. That is mass of dry soils and tear. You guys are going to subtract out the tear. You're going to get the mass of your water, your dry mass. You're going to use your equation to find your moisture content. That moisture content also goes here. And you're going to divide that moisture content out of this guy using this equation. That'll give you your dry mass of soil. You're going to use your you're going to use the equation I gave you out of the lab manual to calculate your soil GSP. And then with that, this is at T1. So you can use that A table out of the lab manual to calculate T at 20. And this guy right here is your final answer, okay? Make sure in your executive summary to come up with your the final answer at T20. Make sure to come up with your moisture content at SSD. Make sure all of this goes into a raw data table, and you calculate all of the necessary values. And that should be it for lab 1 on the fine aggregate / soils. So that's it.